Well, it's that time of year again, the holiday season. Halloween has come and gone, Thanksgiving is this week, and pretty soon Christmas and New Year's will too soon have passed. And in addition to the getting together with friends and family, the much needed rest and relaxation that I hope all of us are having and are getting, and the gift giving, the holiday season always sees a sharp increase in seasonal depression and vitamin D deficiency. Because with the cold winter months that roll in, the sun rolls out. At least in the northern hemisphere, sunlight decreases significantly until the winter equinox, which results in significant portions of the population suffering from vitamin D deficiency and seasonal depression. And so some people this time of year find themselves turning to the tanning bed. Now, I know all of us at some point or another in our lives have heard from people close to us or people on the internet that the tanning bed is bad for you. But is that really true? Is it bad for you? Is it more harmful to you to be in the tanning bed than it is to just go out in the summer under the bright sun without any sunblock? Well, let's talk about the science behind that.
Welcome to The Science Behind That with Atticus Hamilton.
Hello, all you scientists. Welcome on back to the Science Behind That podcast. I'm your host, Atticus Hamilton. And as you heard from the intro, today we're going to be talking about the science behind tanning beds. But first, before we get into that, I just want to say, I think that the last time I did an episode was June 26th, if I remember correctly. June 23rd, sorry. That was my episode on tattoos. And so it's been a while. I hope all of you guys have had a happy Halloween and happy every other holiday that has led up to this day right now. One of the things that I struggle with a lot is consistency. And for those new people joining this podcast, you may not know this, but the veteran listeners that I have, if there are any left that have been with me since my very first episode, know that consistency is definitely something I struggle with. And I've said this a million times because I've taken too many breaks. I've taken a lot of breaks. But I've said this a million times. My New Year's resolution this year is to be more consistent. This community that we have here is not a big one. But the 5,600 of you that, come to me on a weekly basis, or did anyway, to hear more about the world, I owe it to you guys to be more consistent. So, I'm sorry about being gone for 5 months. I really will try, if not to get an episode every Monday and Friday, to at least get one episode a week from now on. But this is also kind of my New Year's resolution as well. But I am going on vacation this week, but doesn't matter. I'm going to do my best to get an episode to you this Friday as well. So for those of you who are still with me, thank you. Thank you for sticking with me as I try and be more consistent. And to those new people, welcome to my podcast. Just to start as well, for the new people and for the YouTube algorithm that keeps trying to take down my episodes, because I don't know. I have a bachelor's degree in microbiology, and I'm also certified in nutrition, and I'm a certified personal trainer as well. And a lot of the topics I talk about are in the realm of biology and health and exercise, but I do like to branch out and talk about everything science. But those are my qualifications right now. And so let's get into today's episode. Tanning beds. So the odds are that out of the 5,000 plus of you that listen to my podcast, at least some of you have used a tanning bed at some point in your life. And I don't know about y'all, but for me, when I was a kid growing up, I was always told by my parents, by my science teachers, and whatnot, that tanning beds are the worst thing for you. And but there was never really an explanation of why, other than, well, there's UV radiation. And young Atticus, being the person that he was, would always be like, well, the sun has UV radiation, but I don't hear you saying the sun is bad for me. What's the difference? So we'll get into that today. But first, I want to talk about a substance in the skin called melanin. Melanin is the pigment that gives skin its color. And melanin is a very interesting compound. So it's a very interesting pigment. And at the end of the episode as well, we'll talk about other interesting physiologies, not in humans, but that we see with melanin, because it's actually kind of cool. But melanin is a pigment. It's a natural pigment found in the body tissues, in the hair, the skin, eyes, but primarily the skin. And it's produced by pigment-producing cells called melanocytes through a variety of biochemical pathways. And the key precursor for the synthesis of melanin in body cells is the amino acid tyrosine. And so in a sort of Spark Notes process of how melanocytes produce melanin, basically tyrosine is converted into dihydroxyphenylalanine, or L-DOPA. Y'all may have heard of L-DOPA before in a great Robin Williams movie about a strange disease that no one really knows what it was in the 1900s. But anyway, tyrosine is converted into dihydroxyphenylalanine, L-DOPA, which is then converted into dopaquinone, and that's an intermediate. And that's done through an enzyme called tyrosinase. And from the dopaquinone step, which is an intermediate, from that intermediate, there's two different types of melanin that forms. It can form eumelanin, which is dark brown or black pigment and is generally associated with UV protection. And we'll talk about why. It's really fascinating. And then pheomelanin is the other type of melanin, and it gives rise to a yellow or red pigmentation. And the reason that is because it incorporates cysteine, which is a sulfur-containing amino acid, has a lot of sulfur residues. And that cysteine amino acid reacts with dopaquinone to form various sulfur-rich melanin derivatives, which gives the pheomelanin its red or yellow pigmentation. And so when you talk about like hair color, skin color, eye color, etc., it's the balance then between these two different melanins, eumelanin and pheomelanin, that creates that color, right? And so that's how melanin is produced. And I want you guys to remember eumelanin, because eumelanin is very interesting. Because of a strange perceived function that we see it used for in the microbiology world, but we'll talk about that again at the end. So knowing that, then, how does the sun trigger into all this, right? So ultimately, when the sun, which is composed of UV rays, is exposed or shines on the skin, basically what happens is it causes the formation of pyrimidine dimers, and which are just, they're, pyrimidine dimers are very similar to free radicals, but it's actually of the backbone of the DNA. So you have pyrimidines, right, and purines. Those are the two categories of bases in DNA. And pyrimidine dimers are when you have two pyrimidines that dimerize. I know, horrible. I'm using the definition, or the word with the definition, which is basically just bond, right? So dimerize is they form a strong covalent bond, essentially. And because of that, it causes a kink in the backbone of the DNA, right? Which can cause, which is considered DNA damage, and it can cause mutations. But ultimately, when that happens, you have a signaling cascade that starts in the nucleus of your melanocytes and extends out into the cytoplasm, that triggers the production of melanin, right? And so it's the keratinocytes and melanocytes that are involved in this. Keratinocytes are just cells in the skin that produce keratin. And the keratin send a signal to the melanocytes to start producing melanin. Why? I'll give you a minute to send me a text why you think that is. If you said it's because melanin protects against UV damage, you're correct, right? So the body does everything to maintain a degree of homeostasis. So if you drink caffeine, if you drink a ton of coffee, like me, and you have a lot of caffeine in your blood, your brain will accommodate so you don't become too aroused by producing other more sedative-like hormones to keep your body in homeostasis. And this is a very well-known phenomenon, and basically, in your body's attempt to keep everything in homeostasis, it allows us to respond to stressors and damage. And in the case of this, sunlight is damage. And then, the melanocytes go and produce melanin using tyrosine in the entire process we already talked about. So knowing that then, right, are tanning beds bad for you? At the end of the day, yes, right? And the reason is because some people will argue sunlight is bad for you, which is a goofy argument to me because vitamin D is dependent upon sunlight. Vitamin D production is dependent on sunlight, right? But there are a bunch of people who say any degree, or who say sunlight is bad for you. Getting a sunburn significantly increases your risk of skin cancer. And it's kind of goofy. It does increase your risk, obviously, but what, we're gonna live our lives huddled under the bed sheets indoors afraid of the sun? No, that's goofy. And again, sunlight is necessary for vitamin D production. But the reason why tanning beds are worse is because the UV concentration that you're exposed to in a tanning bed is dramatically higher than the UV concentration you're exposed to in the sun, right? If I just walk outside and I stroll down the street, I'm a redhead, so I burn really quick. But if we're looking at an average UV index of 5 and I walk down the street, my risk of cancer is not going to be elevated, right? But especially as a redhead, if I spend 5 minutes in a tanning bed, is my risk of cancer going to be elevated? Absolutely. Why is that? It is because the concentration of UV light you're getting from a tanning bed is so much higher than the concentration that you're getting from the sun, even though the sun is obviously bigger than a tanning bed, right? And why is that? It has everything to do with intensity and focal point and surface area, right? The sun is huge. The sun is a very large structure, but it's several million miles away, right? And so because of it, I mean, it's so far away, it takes sunlight from the sun 8 minutes to get to Earth. And so because of it, the effects of it are diffuse. They're diffuse on the human body. Think of it like this, right? If you have an ant on the sidewalk on a hot summer day, it doesn't burst into flames, right? Now, the sun is super strong. It may be getting warm, but it doesn't burst into flames, right? Now take a magnifying glass and focus that light down to a very tiny point on the ant. Burst into flames. Maybe not that dramatically, but it does, actually maybe it does. I don't know. I've never done that. But I've done that on like sticks and leaves. Burst it into flames. Why is that the case? Because the lens of the magnifying glass is concentrating all that sunlight onto a very, very, very tiny point. And it's the exact same idea with a tanning bed. So a tanning bed may have less emitted UV in comparison to the sun as a whole, but the sun is very far away, right? And the tanning bed is right up against your skin. So in that scenario, it's the sun UV exposure on you is the ants on a bright sunny day, and then the tanning bed UV exposure on you is the ants under a magnifying glass on a bright sunny day. And to give you a specific number, tanning beds emit around 10 to 15 times more UV radiation than the sun does, even at its most direct exposure. So this is not this is not like, it emits 3 times more. No, it's 10 to 15 times more radiation. So knowing that then, okay, so Atticus, tanning beds aren't good for you simply because your concentration of UV radiation that you're getting is exceptionally higher than just walking outside in the sun. Well, how much does it realistically raise my risk of skin cancer? Well, let's talk about that. So when we look at the data, a 2005 study by the Agency for Research on Cancer found that a 75% increased risk of melanoma was seen when indoor tanning began being used in early adulthood or during adolescence. And then similarly, another study in 2011 found that the incidence rate of melanoma, or the risk of having melanoma, increased to as high as 75% when tanning beds were being used before the age of 35. So overall as well, several other studies, observational studies, saw a 20% increased risk of cutaneous melanoma in people who had tanned using a tanning bed at any time in their lives. And so, of course, this is not as a scare tactic. This is not as a scare tactic or technique, I guess, to be like, ooh, if you use a tanning bed, you're gonna get cancer. That's not what I'm saying at all. And YouTube, I swear, if you take down this video because I am talking about this, I'm gonna be angry. But no, that's not what I'm saying. But what I am saying is that the data does show a significant correlation between tanning bed use and increased risk for melanoma as well. And again, the phrase, causation or correlation does not mean causation. Well, we already discussed what the physiological mechanism of the causation is, right? So, I think that considering that, I think we can say that these are pretty well correlated and causated. And finally, so overall, then I would say tanning beds, no. If you want to tan, go out, lie in the sun, tan, right? I don't think there's anything wrong with using a vitamin D lamp either. In fact, that's very beneficial. Now, why is that different, right? Because there's two different types of UV radiation. There's UVA and UVB. UVB is more attributed to sunburns and skin cancers and tanning than UVA is, but both of them will still induce vitamin D production. And from the data that I was finding, most of the vitamin D lamps out there emit UVA, which has a much lower risk of skin cancer, because it's not as strong, but it's still strong enough to help with vitamin D deficiency. So overall, I would say don't use tanning beds, okay? Use a vitamin D lamp if you're vitamin D deficient. Drink milk if you can. Take vitamin D supplements. And when it comes to tanning, just tan in the sun, okay? Then the last part of this I wanted to talk about really quick is just a really interesting thing that we've seen with eumelanin. Eumelanin, as I mentioned at the beginning of the episode, is a darker pigment that is very good at reducing harm from UV exposure. Now, the mechanisms for that are a little hazy, and we're still trying to understand how it does that. But something that is really interesting is a species of fungus called Cryptococcus neoformans is part of a very unique group of organisms called radiotrophs. And what is a radiotroph? A radiotroph is, in the most basic sense, an organism that uses radiation for food, for energy, to make its own food. In the same way that a plant uses sunlight to make its own food. Now, plants aren't considered radiotrophs, even though UV radiation is a type of radiation, because radiotroph doesn't use UV, it uses things like X-rays, gamma rays, beta particles, alpha particles. And researchers have found that fungi like Cryptococcus neoformans have very, very high levels of eumelanin. And what they've discovered is that when you irradiate these fungi to levels that would kill pretty much anything else, it increases their growth by 500%, which was very interesting. There was a study that was conducted that irradiated Cryptococcus neoformans to 500 times the level of gamma radiation that's lethal to humans, and it increased its growth rate by 500%. And what researchers are discovering is that the pigment in these fungi, eumelanin, is somehow involved in a energy production cascade using the radioactive particles. And there's other organisms as well that are showing similar behavior. Geobacter bacteria is another example. And they produce eumelanin, and they've been found growing in radioactive radioactive nuclear cooling towers for the spent uranium rods. So there's very interesting physiology. Scientists theorize that these organisms are using eumelanin in a similar way to plants using photosystem 1 and 2 for photosynthesis or chlorophyll, right? But they don't know 100% the mechanism by which it occurs. But what they've also noticed, and this was interesting as well, is that if you cover agar plate with Cryptococcus neoformans and then irradiate the hell out of it, the radiation level underneath the agar plate is pretty much background level radiation, even though the right above that plate is being irradiated. The the fungi seem to be absorbing it. And so this has spurred a bunch of questions into using living walls and spacecraft for radiation protection and whatnot. But it was just an interesting side note that I wanted to talk about that I thought y'all would enjoy hearing. That being said, that is all I have for you guys today. Ladies and gentlemen, I hope you enjoyed today's episode of The Science Behind That podcast. I really enjoyed making it, and, you know, again, I am trying to get better at my consistency, and, you know, I will say that I always love coming back and doing these episodes because I do genuinely love talking to y'all about the science behind everyday life. Have a fantastic Thanksgiving to all my American audience. I hope you get to spend time with family, much needed rest, etc. And I will see y'all on Friday. I promise I will see y'all on Friday with a new episode of The Science Behind That podcast. Thank you guys very much for listening. And remember, as always, stand up and question everything.